Okay. We're going to take a look at some geometric series here. And let's see why this is a geometric series. Now, the first term is A. The second term is AR. We have to verify that the third term is AR squared now. Okay. This is what we're saying. So, if this is geometric, A would be 1/8. AR is negative 1/4 now. Okay, that's a negative value. Replace your A, which is 1/8. So you end up getting the relationship that 1/8 R should be negative 1/4. Now, divide both sides by 1/8, you get negative 1/4 divided by 1/8, which is really negative 1/4, times 8 over 1. What we're saying now is that R is going to be negative 2. All right. So we have all the information we need. We got to verify that AR squared is a positive 1/2 now. So is AR squared equal to positive 1/2? Well, we know A is 1/8. R is negative 2. We have to square that. So we get 1/8 times 4, sure enough, is in fact 1/2. Okay, 4/8 is 1/2. So yes, we have a geometric series now. Now, geometric series converge. We have to verify if the absolute value of R is less than 1. Now, R is negative 2 here. We plug in the negative 2 for R. So what do we see here? That the absolute value of negative 2 is in fact positive 2, and positive 2 is not smaller than 1. So this is a case where the geometric series diverges. So we have a divergent, we'll say diverges. We have a divergent geometric series for question 1. That's divergent because R is negative 2. So we have to check this criteria here. Okay. Question 2 now. Is this geometric? Well, A, AR, AR squared. We got to verify and find the values of A and R to see if it's the third term now. This means A is 1, AR is 0.4. So 1 times R is 0.4. So the radius value, or I should say just the R value, is 0.4. Let's keep it at that. Now, we got to verify the third term. AR squared needs to be 0.16. So, is AR squared 0.16? Well, 1 times 0.4 squared should be 0.6, which means 0.4 squared, sure enough, is 0.6. That is actually true. Okay. So 0.4 to the second power is 0.6. This means we, in fact, have a geometric series here. The series is geometric. Now, if the absolute value of r is less than 1, which means the absolute value of 0.4, which is 0.4, is in fact smaller than 1. So this is a true statement. We're looking for this relationship. So the sum now is a over 1 minus the r value. And r we know is 0.4. A we know to be 1. So we plug in the values for the sum here. So we get 1 over 1 minus 0.4, which is 1 over 0.6, which is 1 over 6/10, which is 10/6, or better yet, 5/2. So the sum value is 5/2. So this geometric series converges, and the sum is 5/2. All right. Very good. Okay. Extra examples. All right, now let's take a close look to this. Let's do a little algebra here on this. This next one, number 3, if we do some algebra, that looks like it's -6 over 5 now to the n minus 1 power here. So the real series, just by doing a little bit of simplification here, is what we see. Now, let's look at the terms here. If we let n be 1, we get -6/5 to the 0 power. Now let n be 2, -6/5 to the first power, n be 3, and you guys get the picture. N is 1, n is 2, n is 3. We're generating terms of the series, which means this is 1 minus 6/5 plus 36 over 25. The next term is going to be negative, but we only need to look at the first 3 terms again. Because if this is geometric, we know we have AR squared now. Okay, so what this means is A is 1, AR is -6/5. Replace this A here with 1, which means R is -6/5. Here's our R value. All right, we got to double check. Is AR squared equal to 36 over 25? That means 1 times -6/5 squared has to be that third term of 36 over 25. Doing some arithmetic, sure enough, we verify that we get 36 over 25. Okay, that means we have a geometric series. The series is geometric. All right. However, we got to check. Is the absolute value of R smaller than 1? That's the absolute value of 6/5 needs to be smaller than 1. 6/5, ladies and gentlemen, is not smaller than 1. 6/5 is like 1 and 1/5, right? As a mixed number. So that is not smaller. It's actually larger. So this is a divergent, this diverges geometric series. Okay, we only have convergence if the absolute value of r is smaller than 1. So this diverges. All right. Okay. Let's take a close look at what this series is. This is under the geometric series questions. By definition, that's 2 over 1 to the nth power here. Let's double check. So the terms is 2 to the first power plus 2 to the 1/2 power plus 2 to the 1/3 power, and this goes on forever. Is this geometric? Well, if it's geometric, we have to verify a few things. Okay? This means a is 2. AR is the square root of 2, 2 to the 1/2. And AR squared needs to be the cube root of 2 now, because that's 2 to the 1/3. 2 times the square root of 2. This certainly is not the cube root of 2. So this series is not geometric. All right. Okay, however, what do we do? I think when we looked at the series here, let me go back to our notes. We had ended with an important concept called the test for divergence. If the limit of an is not 0 or does not exist, then the series diverges. So that's going to give me a nice hint. The limit is not 0. So let's take a look at this here. This is going to be our an. So the limit as n goes to infinity of an is the limit as n goes to infinity of 2 to the 1 over n. Now, as n goes to infinity, 1 over n goes to 0, and 2 to the 1 over n goes to 2 to the 0, which is 1. What we've found is that this limit is not equal to 0. In fact, the limit is 1. So I can just say this. The limit equals 1. It is not 0. So the series will diverge by the divergence test. So they snuck this in. This diverges by the test for divergence, also known as the divergence test. So they snuck it in, ladies and gentlemen. It's good to know. But it's certainly not geometric. So this is kind of the process that you would go through in general. And this is a geometric series, but it involves a variable x here. Let's look at these terms here so I can show you guys what I'm talking about. When n is 1, we have the power 1 there. X minus 4 squared, x minus 4 cubed, and this goes forever. Now remember, geometric series looks like this. well, it's a geometric series here. If we simplify this first term, we get x minus 4 plus x minus 4 squared plus x minus 4 cubed, and so on. It looks like yeah, that's what's going on here. It looks like the tip is having an issue. AR squared. So if you check if this is geometric, you're going to find the following here. A is x minus 4. AR x minus 4 squared. So that means x minus 4 times r becomes x minus 4 squared, and r is x minus 4. Solving for r here. Okay, solving for this. Don't forget, this is my a value. Okay. And so we're going to have convergence now. This is in fact geometric. You say, how do we know? Because AR squared will be x minus 4 times x minus 4 to the second power. That's really equal to equal to, this is going to be AR squared, x minus 4 to the third power. So it does check out. Jeez. Okay, if the absolute value of r is less than 1, we have convergence. And r, by the way, is x minus 4. So what does this mean? It means the absolute value of x minus 4 needs to be 1. This is an absolute value inequality. It means x minus 4 is between -1 and +1. We can solve for x by adding 4 to the left, the middle, and the right. We get 3, ladies and gentlemen, is less than x, which is less than 5. So we're going to get convergence here for these values of x. But what is the sum going to be? Okay? The sum, let's remember that S is A over 1 minus R. A is what? X minus 4. So here, replace it with an x minus 4. R we found out was also x minus 4 over here. So just doing a little arithmetic, we get x minus 4 over 1 minus x minus 4. The sum's going to be x minus 4 over 1 minus x plus 4. Your sum's going to be x minus 4 over 5 minus x. Geometric series with the variable x. All right. So this equals x minus 4 over 5 minus x for 3 less than x less than 5. Okay, this is what they're looking for. This is what the sum is. It converges for these values of x. It's a geometric series. All right. Is this a geometric series? The answer is yes. You're going to find out, ladies and gentlemen. The first term, x minus 3 to the first power. The second term, x minus 3 squared. The third term, x plus 3. This is a, this is AR squared. A is x plus 3. R is another x plus 3. AR squared will check off. Now, if the absolute value of R is less than 1, what does that mean? We're looking for the absolute value of x plus 3 being less than 1, which means negative 1 less than x plus 3 plus 1. If I subtract 3 from the left, the middle, and the right, we'll get negative 4 here, less than x, less than negative 2. Let's write that a lot better. Negative 4, this is what the iPad does. It wants to do this. Come on. Negative 4, less than x, less than negative 2. I guess we have to write slower. We'll get convergence for these values of x. Now the sum, s, has to be a over 1 minus r again. So it means our sum needs to be x plus 3 over 1 minus x plus 3. Just using a little arithmetic, little algebra, distribute. The sum's going to be x plus 3 over, looks like it's going to be 1 minus 3, negative 2 minus x. Anyway, we'll just keep it like that. So we converge to this particular sum for these values of x. All right. Number 7 now. We could do just a little bit of algebra here in number 7. So we have x minus 3 over 2 now, raised to the nth power. So we're looking at the series here. 1 to infinity. All right, let's look at the terms. X minus 3 over 2. X minus 3 to the 2 to the second power. Third power, and that goes forever. AR squared. You're going to find that this is geometric, where the A term is x minus 3 over 2. The R term is x minus 3 over 2. So this is going to be a geometric series. Okay? You'll get convergence for the absolute value of r being less than 1, which means the absolute value of x minus 3 over 2 needs to be smaller than 1 for convergence. All right, properties now. X minus 3. There's our iPad game again. Let's go up here. X minus 3 in absolute value over 2 needs to be smaller than 1. I can solve for the absolute value by multiplying both sides by 2, and then 2 times 1 is 2. An absolute value inequality, by definition, negative 2 x minus 3 is less than positive 2. So we can add 3 to both sides. In fact, it's the left, middle, and the right. You'll get convergence for values of x that are between 1 and 5. You're going to get convergence here. Okay. The sum, if we look at that, what it'll converge to? A over 1 minus r. Well, A is x minus 3 over 2 over here. R is the same thing. So there's going to be some algebra here. X minus 3 over 2 over 1 minus x minus 3 over 2. All right. Still a little algebra here. X minus 3 over 2 over 2 minus x minus 3, everything over 2. 2's cancel. The sum is x minus 3 over 2 minus x plus 3, because we're going to distribute that negative sign. So your sum will be x minus 3 over 5 minus x. So we're going to get convergence to this particular sum depending on the values of x, where x needs to be between 1 and 5. All right, geometric series. Okay, now let's look at the last one here. And I'm going to have to get to this one at a later date because I have somebody at the door. So I'll send this to you guys now.